All right. This is the first type of elevator problem we're going to review. And this is used to find an elevator problem where you need to find an acceleration. So the problem here is, I'm a student, rides an elevator up. It starts from rest and accelerates upward. The bathroom scale reads 800 newtons. What is her acceleration? Now, just like all of our problems, we're going to start with a force diagram. And since she's accelerating upwards, the forces should be unbalanced. And because it's accelerating upwards, the force can be unbalanced upwards, which means the surface force will be greater than the gravitational force. If we take these and add them together tip to tail, we're going to get a net force diagram that looks like this. And because the upward forces are greater than the downward forces, we'll have a net force that is upward. Now, using our usual reference frame, we're going to find our net force equation. And we'll see that in the y direction, the surface force subtracted from the gravitational force will equal our net force. All right, we're ready to go to the next step of the problem. First, we'll calculate the weight. We know how to do that using W equals 8 mg. And so we take the mass of 60 kilograms times the gravitational constant of 9.8 meters per second squared. And when you multiply them, you're going to find out that that's 588 newtons. Next, we're going to use Newton. We're going to substitute into our net force equation. Okay, because from the problem here, we know that we have the scale reading is 800. That's the surface force. And we know the gravitational force is 588. And so when we substitute that in, we subtract 588 newtons from 800 newtons, finding that the net force, when you subtract them, is 212 newtons. Now we're ready for the last step. And the last step will be to substitute this into Newton's second law. Since we're solving for an acceleration, we'll use the acceleration form of Newton's second law. A equals F net over m. And we're going to simply substitute in 212 newtons over 60 kilograms. That's going to get us, the calculator will give us 3.53 meters per second squared. We're going to round that, since the 60 kilograms, we only have 2 digits there. We're going to round that to 2 digits here. So that should be 3.5 meters per second. And that's our acceleration. So in this type of problem, we're going to use our net force diagram. We're going to use our net force equations and then substitute into Newton's second law at the end. And that's it for this part of, for solving this type of problem.